Alright, in this section we're looking at Leaving Cert Ordinary Level Compound Interest, and it's on page 117 of the book, and questions for you to try will be on page 120. 121. Okay, so before I explain what these terms here that I've written out mean, I'm just going to give a basic idea of what compound interest is. So if I walk into the bank in the morning and put €100 into my account, the bank is going to give me money for leaving that €100 there, because it suits the bank to have my money, because then they can give it out as loans to other people. So the bank is going to pay me a small amount of money every year that I leave my €100 in the bank. And the way they're going to calculate how much to give me is based on an interest rate. So for example, if I walk into the bank with my €100 on the 1st of January and the bank gives me 5% interest, that means at the end of the year the bank is going to give me 5% of what I put in. So instead of me having that €100, they're going to give me 5% of €100, which is €5, and I'll now have €105 at the end of the year. But that means if I leave it there for a second year, they're not going to give me 5% of €100 anymore, because I don't have €100 anymore. I have now got €105. So that's why it's called compound interest, because each year the amount that I have in the bank gets increased and increased and increased, and I'm going to get the interest rate on the new amount each time. So let me just give you that exact example again, just by writing it out so you can see what I'm talking about. So at the start of the year, on the 1st of January, I put €100 into the bank account, and the bank is going to give me 5% interest. That means if I leave that €100 there for the whole year, the bank is going to give me 5% of €100, which is €5. So the bank will give me €5, which means on the 1st of January the next year, so let's just say 2018 and pretend this one was 2017. On the 1st of January 2018, I now have €105 in the bank, and the bank will give me 5% of that. And that's why it's going to increase each year, because at the end of the third year then I'm going to have even more money, and at the end of the fourth year I'm going to have more money, and so on and so on. So that's what compound interest is. So I'll just explain what these terms are up here first before we get into it. So the principal, that's the amount of money that we go into the bank with. So for example, the €100 that I was putting into the bank a minute ago, that's known as the principal. Alright, and actually I've spelled that wrong. There should be AL instead of LA. Yeah, so the principal, it's the amount of money that we invest, save, anything like that. It's the amount we put into the bank originally. The rate, or the interest rate, that's the amount the bank is going to give us, and it's generally going to be 4 or 5 or 7.5 or something like that, that amount as a percentage. And just to remember, if it's 5%, you might see that written as 0.05 when you write it as a decimal, because as a decimal 5% is 0.05. Remember, 5% is just 5 over 100, and 5 divided by 100 is 0.05. And then the last term that we have is the final amount. The final amount is the amount of money I'm going to have at the end. So if it's only there for 1 year, and I'm using my example from a minute ago, the final amount is €105. So before I go in and explain how we do compound interest and how we work out how much money we'll have after 3 years or 4 years and so on, I just want to remind you of a simple thing from percentages that you would have seen before. I know that I had €100 in the bank, and the bank is going to give me, so I'll get added onto that, 5% I'll actually just write this out differently, sorry. The bank is going to give me 5% of €100. So the way you would normally do that on your calculator is you'd say, okay, there's the 100 I started with, plus, and then on your calculator you'll say 5% multiplied by 100, and that will be €5. And then you'll have to add the two of them together to get €105, the amount you have at the end of the year. Or let's pretend you had €300 at the start and there was a 5% interest rate. Well, that means you're going to have 300 plus the interest that the bank gives you. Okay, and 5% of €300 is €15. So at the end of the year you'll have €315. But the problem with that way of doing it out is that when you get the percent, you then have to add it on. So 100, and then you have to add on the 5. Now that's easy enough for you to do in your head, just adding on €5 to 100. But when the examples get a bit more complex, it'd be easier if we had a shortcut that we didn't have to keep adding it on. If we could do the 2 steps in one, if we could get the percent and add it on at the same time. Well, there is an easier way of doing it, and just think about it like this. What is this €105? It's my original 100 plus my €5. Or if I look at it in terms of percents, it's my original money, which was 100% of what I had, plus 5%. So €105 is 105%. Or down here, that's really €300 plus €15, which is 100% the money I had at the start, plus €15 is 5%. So really, €315 is 105%. And if we don't believe that, let's just check it. Instead of doing 5% of 100, let's see what 105% of 100 is. And if you do that on your calculator, the calculator comes back straight away with 105. It gets the percent and adds it on for you at the same time. Down here, if you do 300 multiplied by 105%, the calculator will say 315. It will find out that 5% is €15 and it will add it on for you. So what I'm trying to explain to you is if the interest rate was 6%, so the rate is 6%, and let's say we started with €200 in the bank. Well, at the end of the year, I'm going to have 6% of 200. So I'm going to get off the bank 6% of 200. Okay. But not only that, once I do that, I'll have to add the answer on. Okay. So 6% of 200 is €12. And now what I have to do is, okay, I have to add them on. At the end, we'll have the 200 plus the 12. We'll have €212. What we're trying to say here is that the faster way of doing it is instead of getting 6% of 200, get 106% of 200. And the calculator will come back with 212 for you. It will add them on for you. And just remember, 106% as a decimal is actually 1.06. And up here, 105% would be 1.05. And up here, it'd be 100 by 1.05. So just to quickly tidy up what I'm saying. If I want to find 7% compound interest, I'd multiply my principal by 1.07, which is 107%. If I wanted to find 6.5%, I'd multiply my principal, the amount I put in, by 1.065. Okay, if I wanted to find 13% interest, I'd multiply my principal by 1.13. And this is going to be very important in a minute. Okay, so let's do an example. Now I'm not going to do the formula on this, I'm just going to show it the long way, and then we'll come up with a nice easy formula for doing compound interest. So I walk into a bank and I put €300 into the bank. So the 1st of January 2015, we'll say, I put €300 into the bank. It's going to be there for 3 years, and the interest rate is going to be 5%. So we could do this out the long way. I could say, right, €300, it's going to get 5% every year. So at the end of year 1, in December of 2015, I'm going to get 300 multiplied by, and remember from the example I was just saying here, if I want 5%, I multiply my principal by 1.05. So that's how much money I will have in December of the first year, and that would be €315. But now I'm starting year 2, 1st of January 2016. I'm not starting with 300 anymore, I'm starting now with 315, and I want to multiply that by 1.05 because I'm still getting 5% interest, and that's going to come back as €330.75. So that's how much money I'll have at the end of the second year. In December of 2016, I'll now have €330.75. And then on the 1st of January 2017, I'll be starting the year with €330.75, and I'll be getting 5% interest on that. And remember, to get 5% interest, we multiply by 1.05. And that means I'm going to come out at the end of that year with €347.29. So that's how compound interest works. Okay, I don't just keep getting 5% of 300. I don't add €15 on 3 times, because if I did, I'd only have €345. Really, I should be getting €347.29. Now I want to do this out in terms of the formula. Okay, so let's try and figure out where the formula comes from. There is a formula for working out compound interest. It's in the tables, and it says that the amount you have at the end, the final value, is equal to the principal, the amount that you put in, by 1 plus r to the power of t. So t is the number of years that the money is going to be in the bank, or if you're dealing with months, the number of months that it'll be in the bank. R is the interest rate, 1 is just 1, P is the principal, the amount you put into the bank, and F is the final amount that you have. I want to try and explain where that formula comes from, but I'm just first going to show you that it is true. The final amount, when I put €300 into the bank, I'm using the same example as a minute ago, 1 plus R is 5%, as a decimal that's 0.05, to the power of 3, because it's there for 3 years. So 300, 1 plus 0.05 is 1.05 to the power of 3. And if you do that on your calculator, you come back with 34729. It's the same answer as we had in this longer example up here. Okay, so this is the formula we will be using, but I just want to explain to you where that formula comes from and why it's true. So, using the example of the €300, let's just have a look at this. So, at the end of year 1, when I put €300 into the bank, I now have 300 by 1.05, which we know works out to be 315. That's what I have at the end of year 1. So that means at the start of year 2, I must have €315. So if I were to write that, at the start of year 2, I have €315. And I want to get 5% of that, so I'd be multiplying that with 1.05. But remember, 315 is 300 by 1.05. This is very important. So look, 315 is 300 by 1.05. If you do 300 by 1.05 on your calculator, you will get 315. So these are the same number. So that means over here, instead of writing 315, I could write 300 by 1.05 because that is 315. And then I want to multiply by this 1.05. So it would look like that. So basically, at the end of year 2, I have 315 by 1.05, and we know that will work out to be €330 and 75 cents. And then for year 3, I'd have to multiply 330.75 by 1.05 again. But why multiply 330.75 when this entire thing here is 330.75? This number is 330.75. So instead of 330.75 here, I could write 300 by 1.05 by 1.05, and then don't forget this new 1.05. So do you see what we have here? We basically have, at the end of year 3, we have 300 by 1.05 by itself 3 times, or in other words, 1.05 cubed at the end of year 3. At the end of year 7, we would have 300 by 1.05 to the power of 7. At the end of year 30, we'd have 300 by 1.05 to the power of 30. And that makes it a lot easier for us. And that's where we get the formula from, because if you look, this number here for year 3 is the same as what we had up here, 300 by 1.05 cubed. And that's why this formula works. Okay, I'll ask you to study this part here, and if you don't get it, do ask me, because it's important that you understand why this formula works. So the formula for compound interest, it is in the tables if you forget, but it's P, the amount you put into the bank, by 1.0, well sorry, I'm doing 1.05, it could be anything. It'd be 1 plus whatever R is, so if it's 7%, it's 1 plus 0.07 or 1.07. If it's 12%, it's 1.12 and so on, to the power of T, the amount of time you have it in the bank. So I'll do an example just so you can see. So find the compound interest on €2,800 for 3 years. So this is in the bank for 3 years at 7.5% interest per year. So using the formula, the final amount that we will have is equal to the amount we put in by 1 plus r to the power of t. And just as important, this r is the interest rate in decimals, not in percent. So in this example, P, the amount we put in, is €2,800 by 1 plus 7.5% as a decimal is 0.075 to the power of 3 because it's there for 3 years. So that's equal to 2,800 by 1.075 because 1 plus 0.075 is 1.075 to the power of 3. And that's going to work out at €3,478.43. That's how much money you will have in the bank at the end of the 3 years. But be very careful, this question didn't ask us how much money we would have in the bank. It asked us to find out how much was the interest worth. Well, if I have €3,478.43 and I only started with €2,800, well then the rest of it must have been interest, so the interest must be €678.43. So just be careful, is the question asking you how much do you have in the bank, or is the question asking you how much interest did you earn? So let's try another example. So what amount of money do you have to put into the bank? So in this case we don't know what P is. I'll just write the formula first. F is equal to P by 1 plus R to the power of T. So this question is asking me how much money, if the interest rate is 4%, how much money will I need to put into the bank so that after 3 years, so T is 3, it will be equal to, the final amount will be €3,149.62. So how much money do I need to put into the bank if I need to have €3,149.62 in 3 years with 4% interest rate from the bank? So P is the thing I don't know in this question. I don't know how much I need to put into the bank in the first place. I do know how much I want to have at the end. I do know how long it needs to be there, and I do know the interest rate. So let's just fill in what we know into the formula. Remember the formula, F equals P by 1 plus R to the power of T. So in this case, F is €3,149.62. That's how much I need to have as my final amount. P is an unknown, so I'll just leave it as P. 1 plus R. R is 4%, which is 0.04. So 1 plus 0.04 is just 1.04 to the power of 3. So that's just an equation. There's an equal sign here. And when there's an equal sign, we just do the same thing on both sides, and then we can't go wrong. So remember, I would like this here to be on its own. I want to know what P is. So that means I'd love to be able to get rid of 1.04 to the power of 3. Well, that's easy enough to do because I have an equals. It's an equation. So if I divide the right hand side by 1.04 to the power of 3, they'll divide into each other once. But because I've divided the right hand side by 1.04 to the power of 3, I need to divide the left hand side by 1.04 to the power of 3. So what are we left with? P, which is on its own on the right hand side, will be equal to 3149.62 divided by 1.04 to the power of 3. So if I want to have €3,149.62 at the end of 3 years, I will need to save €2,800. Alright, so P is €2,800. That's how much I need to put into the bank today if I want to have €3,149.62 in 3 years' time. Okay, and that's compound interest. And I just want to point out, sometimes you might hear of a thing called depreciation. Like if you buy a new car, the minute you drive it off the forecourt of the garage, the car starts to go down in value. Just like the money you put into a bank goes up in value, well, a car can go down in value by the same amount. Alright, so but we use the exact same formula. So the amount it's finally worth at the end is equal to the amount it was worth when it was new by 1, but instead of doing 1 plus r this time, because the amount is going up each year for interest, we'll do 1 minus r, because with a machine or a car or things like that, they go down in value. So you're not going to be doing 1 plus r to the power of t, you're going to be doing 1 minus r to the power of t. So for example, a machine depreciates in value by 10% every year. So r is 10%, the rate that it goes down every year. So this machine goes down by 10% every year. At the end of the 3 years, it's only worth 58,320. So that's the final value, how much the machine is worth at the end, F. 58,320. And this is after 3 years. We want to know how much was the car worth when it was new. Oh, sorry, the machine, not the car. So when it was new, that's P. The amount you invested at the start. Oh, hold on, I'll just write that again. The amount you invested at the start, P. Nope, there's something wrong there. Try one more. So, what is P? How much did you invest in the machine at the start? How much did you buy the machine for? So F is equal to P by 1 minus R to the power of T. So 58,320, remember that's F, the final value of the machine after the 3 years, is equal to P by 1 minus R. If the interest is 10%, as a decimal, that's 0.1. So it's 1 minus 0.1 to the power of 3. So it's 58,320 is equal to P by 0.9 to the power of 3. 1 minus 0.1 is 0.9. And just like in the last example, I have an equation here. So if I want P on its own, I need to get rid of 0.9 to the power of 3. So I'm going to divide that side by 0.9 to the power of 3. But because an equation is there, it has to be balanced. So whatever I do on the right, I need to do on the left. So I'm going to divide the left by 0.9 to the power of 3 also. Over here, they'll divide into each other once. So I'm left with P by 1, or just P. And on the left, 58,320 divided by 0.9 to the power of 3. Well, that's 80,000. So in other words, you bought this machine for €80,000, but 3 years later, it's only worth €58,320. And it was the exact same formula, but the only difference is, instead of this being a plus, it's a minus, because the machine is going down in value, whereas plus, it's going up in value. Okay, so that's depreciation. And then there's only one other thing that you might be asked about, and that's sometimes you have this idea of a monthly interest rate. Okay, so sometimes it isn't done yearly. the interest rate is given to you every month. So instead of €100 getting interest once, you might be told it's 2% per month. So the rate is 2% per month. So if it's in the bank for a year, you'll be multiplying by 1.02. Remember, 2% is 1.02. But instead of doing that for 1 year, you would have it there for 12 months. So you'd do this 12 times. So just be careful. Are you doing a yearly interest rate, or are you doing a monthly interest rate? Okay, if it's yearly or annually, it's sometimes called AER, or the annual equivalent rate. You'll see it in the question though. Just look for it. Are you doing this monthly, or are you doing this yearly? Is the interest rate applied monthly, or is the interest rate applied yearly? Okay, so the questions to try on that are starting on page 121 and they go to 124. And again, if you have any questions, you just come up and ask me. Just go back over the video, but just come up and ask me then. Even if I'm still with the higher levels, just come up and ask me and I'll answer it. Alright.